Hello. Today we're going to talk about solving literal equations. This is going to be the last topic that we go over before we finish Unit 1, and we'll have a test next week over it. So we're going to look at some examples of what literal equations are. So here are some examples. Y equals mx plus b, a equals bh, c plus 5 over d equals 12. So those are three examples of what a literal equation is. So let's look up some examples that are non-literal equations. So some non-examples, we have g minus 11 over 3 equals 20, 196 equals 8w, 3.5x minus 4 equals 10. So if we're doing this in class, based on your observation, what do you think makes something a literal equation? So looking at both the examples, the thing that I am noticing is in the literal equations, there's multiple variables, as opposed to in here, there's only one variable per equation, but multiple different constants or coefficients. So a literal equation is pretty much the base of a formula. It's an equation that includes multiple variables, and you're solving for a specific variable. So for these, you only had one variable, so you were just solving for example, w, or just solving for g, or just solving for x. Over here, you have multiple variables, and we'll tell you which one to solve for. We might say solve for x, we might say solve for m, b. We wouldn't say y because y is already by itself, but you would be isolating one variable out of all of them. So, literal equations. A literal equation has more than one variable and can be rearranged to solve for a specific variable. Formulas are great examples of literal equations. List at least 3 literal equations that you've seen or used before. So you can put those in the chat when we go ahead and do those. Some examples are a linear equation, y equals mx plus b. That's a literal equation. We have the area, length times width. We have the perimeter of something. So if you have a triangle and you want the perimeter of a triangle, you'd be doing 3 times the side length, so 3s. There's a lot of different options for a literal equation. It just depends on the formula that you're looking for. There's one that you might have heard from Einstein, E equals mc squared. That is a literal equation. And it's just something that you're gonna have to isolate something in order to solve. So, trying to make sure my face isn't covering anything up. So let me move me over to the side. So we're gonna get each table has gonna have a pair of equations, and we're gonna solve the first one, and we're gonna use the same rules to solve the second one. So over here we have 144 equals 4b. So in order to solve this, we need to get rid of the coefficient. So to get rid of the coefficient, we're gonna divide both sides by 4. These 4s are gonna cancel out, and 4 goes into there 36 times. So you're gonna have 36 equals b. So we're gonna apply the same rules to when we're solving d equals ef, and we're solving it for f. It tells you right here, this is the variable that we're looking for. So we're gonna go ahead and we're gonna isolate f. In order to do that, we're gonna treat e as our coefficient. So we're gonna divide everything by e. Now these are different variables, they're not like terms, so we are not able to simplify, we're just gonna leave it as that. We're gonna go ahead and we're gonna cancel out our e's, and we're gonna say our answer is d over e equals f. And that's done. As long as your variable is isolated, you have completed it and you have solved. You're not gonna get a numerical value because you have multiple variables. So you're just trying to isolate a variable. So let's do some more. We have 13x plus 9 equals 100. First thing I notice is that we need to get rid of our constant. So we're just gonna subtract 9 from both sides. 9's cancel, you're left with 13x equals 91. Now I gotta get rid of my coefficient, which is 13. So I divide both sides by 13. And when I do that, I'm gonna get, my 13s are gonna cancel, I'm gonna be left with just x. And 13 goes into 91 7 times, so I have x equals 7. So we're just gonna apply the exact same rules to this equation. It's the same kind of format, we're just applying the rules. So we have mx plus b equals y. We're trying to isolate the m because that's what it says right here. So first we're going to get rid of our b just like we got rid of our 9. Now we can't really subtract b from y because they're not like terms. So the way that we're going to write this when these cancel out is going to be mx equals y minus b. We're just going to write them next to each other. We don't know those values, so we can't simplify them. We're just going to leave it as y minus b. Now, just like over here, we got to get rid of our coefficient. Since we're trying to solve for m, our coefficient this time is going to be x. So we're going to divide both sides by x. Our x's are going to cancel. We'll be left with just m, so m will be isolated. And we're going to be left with all this on the other side. So m equals y minus b over x. And like I said, it won't be a simplified version. You can't simplify when you have multiple variables because they're not like terms. So all we're concentrating on is isolating our variable. Our m is alone, so we have isolated it. So let's do another one. We have 360 equals 5 times 12 times h. This is all multiplication. So we have 360 equals 5 times 12 times h. Well, I can divide by 5 times 12, and that's going to get h by itself. So divide both sides by 5 times 12. Now, I can go ahead and I can plug, after this cancels out, I can plug all this in the calculator. 360 divided by 5 times 12. I'm going to get 6, so I have h equals 6. We're going to apply the same rules over here. We have v equals LWH. We're trying to isolate h. So we're multiplying both by L and W. So we're just going to divide both by L and W. And when we do that, our L and W's cancel out, and we're left with v over LW equals h. And the h has been isolated, so we're done with that. So these should be simpler or easier to complete because you're not actually solving for a numerical value. And I know solving for a numerical value can get a little confusing, especially with multiplying and adding multiplying a negative, multiplying and adding a negative. There's different things that may confuse you when actually solving and evaluating a number. So these, all you're doing is isolating the variable, not having to actually solve, just get it by itself. So over here, 7 equals 2 times 7 plus 2n. We're just going to bring it down. But when I bring it down, I'm going to go ahead and distribute this 2. So that's going to be 7 equals 14 plus 2n. Now I'm going to go ahead and subtract 14 from both sides, just like we've been doing. This is going to cancel. This is going to leave me with 56, and 56 equals 2n. Got to get rid of our coefficient, so we're going to divide both sides by 2. 2's cancel. 2 goes into 56 28 times, so I have 28 equals n. Like I said, we're just going to apply the same rules. The only difference is we don't have to distribute because we don't have numbers that we're able to figure out. This is already m times j, and I don't have to do anything simpler than that. So what I'm going to do over here is first I want to isolate my k. So I'm just going to subtract mj together. So when I subtract mj together, these cancel out. These are not like terms, so it's just going to be h minus mj equals 2k. We got to get rid of our coefficient just like we did over here. So we're going to divide both sides by 2. Our 2's are going to cancel. And we're just left with this. H minus mj over 2 equals k. So we have 75 equals x over 2. So this is a fraction. When we have our equation, we just need to get rid of the denominator. In order to do that, we need to multiply by whatever's underneath. So we're going to multiply both sides by 2. Our 2's over here cancel. We're left with just x. 2 times 75 is 150. So 150 equals x. So we're just going to apply the same rules over here. We have t equals q over r. We're trying to isolate q. So we're just going to multiply both sides by r. R's over here are going to cancel. And we're just going to have r times t equals q. These ones get a little bit more complicated when we throw in the squared symbol. We need to know that when you have a squared symbol, the way that you undo that is with a square root. And I'll show you what that looks like. So first, we got to go ahead and get rid of our constant. So we're going to subtract 144 from both sides. That's going to cancel. We're going to be left with c squared equals 25. This is where the square root comes in place. We need to get rid of this 2. So we have to square root to cancel out the square. So this is a square root symbol. Square root symbol, these are going to cancel. And the square root of 25, and we'll go into more about square roots later on. If you're not sure about what perfect squares are, the square roots, you can always plug them in your calculator, but the square root of 25 is 5. So we're going to have c equals 5. So we'll apply the same rules. We have x squared plus y squared equals z squared. We're trying to isolate the x. So we're going to subtract y squared from both sides. Our y squareds over here are going to cancel. We're left with x squared equals z squared minus y squared. And then we just got to go ahead and square root them to cancel out the squared. Now I'm only going to cancel out this squared because I don't know what's going to happen here yet. So I'm just going to cancel that, and I'll just leave this as it is. So I'm going to have x equals square root of z squared minus y squared. And that's it. You're done with that. So as long as you know, in order to get rid of a square, you're going to do the square root. And you just apply that square root over everything on the other side as well. Okay, so we're going to solve two more problems. So we have I equals PRT, solving for t. So we're going to isolate the t. So we're just going to divide by everything that we want to get rid of because it's all multiplication over here. So we're going to divide both sides by PR. When we do that, the PRs cancel out. And I'm just left with I over PR equals t. See, not too difficult. So let's do another one. We're isolating the y. So I'm going to start by getting rid of my x. So I'm going to subtract 8x from both sides. These cancel. I'm left with 4y equals negative 12 minus 8x. Then I'm going to divide both sides by 4. These 4's cancel. 4 goes into negative 12 3 times, or negative 3 times, and 4 goes into negative 8 negative 2 times. So we're going to have y equals negative 3 minus 2x. And y is by itself. So these aren't too difficult, and you can get more with practice. We're going to be doing some IXL practice later on. But in the chat, the things I would like us to discuss is to compare and contrast the differences between solving equations with one variable and literal equations. I would like you to write in full sentences. So when we're in class, this is something that I want to discuss. So some similarities are you're going to be using the same steps that we normally use, such as do not call me after midnight steps. You're going to add or subtract to get rid of your constant. If there's anything you need to distribute, you can distribute it. That'll be first. If there's like terms, I doubt there will be with literal equations, but you can combine them. If you have variables that you're trying to isolate on both sides, you would move it to one side, but that's also probably not going to happen. You're just going to mainly have multiple different variables. And then you're going to have to multiply or divide to get rid of your coefficient. So similarities are the steps that you take to solve. The difference is there's less simplifying when you're going ahead and solving literal equations because you don't have values to simplify. You don't have like terms. So there is going to be differences in less simplifying. So that's what I noticed is that it's a little bit easier to do the reverse operations for a literal equation to get the correct answer because it's easier to not get lost with all the different numbers that you're seeing floating around when you're solving an equation. Y'all might have noticed some other stuff. So I would love to see what you noticed when you watched those problems be solved or when you were solving any problems of your own. So feel free to write that in the chat when you come into class if you've already watched this video. So now, as always, when we're in class, and if you want to start now, I will go ahead and I can always give you these links if you email me if you want to do some practice, or you can even just look up literal equations, and I'm sure you can find some practice problems on IXL. But on IXL, I want you to master equations, literal equations. So you're just going to use your notes and try to do your best. Don't be scared ever to ask for help. You know you can do this. I have tutorials between 1 and 2 every day. If you're struggling at all, I would love to see you there. And we have a test next week over solving equations, solving inequalities, and literal equations. So if there's anything that you specifically need help on, just let me know. I hope you have a great day, and thank you so much for watching.